In this section, we're going to talk about using trigonometry to solve story problems. So we're going to use all of the skills we've talked about in the last three sections to set up equations and answer questions about more realistic situations. So there are three main vocabulary terms you need to know. The first one is angle of elevation. So if you look at this diagram right here, this angle between the ground and the line of sight up to the top of the tree is called the angle of elevation. So any angle between a horizontal line and the line up to an object. So you can think of it as elevation. An elevator goes up. So an angle of elevation always goes from a horizontal line up to a line up to an object. So they're always measured upward. And generally, you're going to be drawing a triangle that will have like an object you're trying to find the height of on one side and the ground on the other side, and the sight line as the hypotenuse, and the angle of elevation will be inside that triangle. The next vocabulary term you need to know is one that people get confused on quite a bit, and this is called the angle of depression. So let's say you were standing in this lighthouse right here, and you're looking down from the lighthouse to this boat on the water. Well, the angle of depression is if you drew a horizontal line straight out from the top of the lighthouse and you measured the angle downward from horizontal to your line of sight, that's the angle of depression. So notice it's outside the triangle. It's not the one in here. Everyone always thinks it's the one in here. It's not. It's the angle between a horizontal line. So you always want to draw a horizontal line, a flat line going out. Always draw that flat line going out and then draw the angle down to the line going down to the object. And that angle out here is the angle of depression. So sometimes when people are depressed, you say, oh, I'm really down today. So angles of elevation are measured downward from horizontal. And a lot of times, if you're drawing this triangle right here, the angle of depression is going to be outside that triangle. Now, if you look at a diagram and you put both angles on, you'll see that this horizontal line and this horizontal line are parallel. And if you remember, when we talked about parallel lines, that was a really good line right there. Those are so parallel. If you have two parallel lines and they're crossed by a transversal, this angle and this angle, they're both inside the two lines. They're between these two, so they're interior angles. And one of them's on the left of the transversal, on the left, one of them's on the right of the transversal. So we say they're alternate interior angles. And when these two lines are parallel, those are the same size. So it turns out if you have a certain situation here, the angle of depression and the angle of elevation would be the same size. So here's an example right here. This angle, the angle of depression from the top of the cliff down to the object measures 34 degrees, and the angle of elevation from the object to the top of the cliff measures 34 degrees. So that angle of elevation and that angle of depression are congruent. They're the same size. So that's something handy to keep in mind that can help you when you're setting up your diagram. The last vocabulary word you want to know is just the vertical drop, and that's kind of another word for height. It would just be from top to the bottom of an object. So when you're solving a story problem, your steps are draw a diagram. It doesn't have to be beautiful. As you probably have figured out by now, my artistic skills are a little bit lacking. Stick figures are great. Don't even feel like you really need to draw trees or anything, just mostly draw triangles. That's good. Label the sides and the angles you know, and label the side or the angle you want to find out with a variable, an x or a theta. And then write an equation. So if you know two sides of the triangle and you need the third side, use the Pythagorean theorem. So for instance, if you had this situation right here, and this side was 5.2 and this side was 7, and you're trying to find x, you could write the equation x squared plus 5.2 squared equals 7 squared. If you know one side and one angle, and you are trying to find another side, you would use sine, cosine, or tangent. So for example, let's say you had a 72-degree angle, and the side opposite that angle you were trying to figure out, and the hypotenuse was 14.3. Well, opposite over hypotenuse, opposite over hypotenuse is sine. So the sine of this angle would be x over 14.3. You would get that equation right there. And you also might have a situation where you're trying to figure out an angle of elevation or an angle of depression. So for instance, maybe you have this triangle right here, and you know that this side is 15.3 and this side is 26.2, and you're trying to figure out how big that angle of elevation is. So you'd go, okay, well this side's opposite and this side's adjacent. So to get that angle, I would use tangent. Tangent is opposite over adjacent. And you want to tell your calculator, hey calculator, I know what the tangent is. You tell me the angle. That's when you would use the inverse tangent. So these are three different types of situation that you might see in these problems. So we will look at examples of all of these. Once you have your equation set up, you will go ahead and solve it. And of course, these are story problems, so you don't want to forget units on your answer. So here's our first situation. We have a dog, and the dog is 7 meters from the base of a tree. And the dog sees a squirrel in the tree at an angle of elevation of 50 degrees. All right, so we've got a dog, which I can't draw, so I will very cleverly write dog. And we've got this tree. And somewhere up in the tree, we have a squirrel. Oh, that's a lovely drawing. Yes, okay. So we have a 50-degree angle of elevation. The dog is 7 meters from the base of the tree. And we want to know what the distance between the dog and the squirrel is. So that would be this distance right here. So I've got a triangle. There's my right angle. I want to think about what sides are involved in this problem. Well, x is across from the right angle, so x would be the hypotenuse. And the 7 is right next to the 50 degrees. So 7 would be adjacent. Well, think about what we should always keep in mind when doing trigonometry. SOHCAHTOA. I've got adjacent and I want hypotenuse. That means I'm going to use cosine, adjacent and hypotenuse. This is a problem. So the cosine of 50 degrees will equal the adjacent side, which is 7, divided by the hypotenuse, which is x. X is on bottom, so this is going to be one of those two-step problems. Multiply both sides by x. And you get x times the cosine of 50 degrees equals 7. And then your second step is to divide both sides by cosine of 50 degrees. So you get that x is equal to 7 over cosine of 50 degrees. Which is about 10.9 meters. Make sure you check your units. I know we're always tempted to use feet on every problem, but it might be meters. Now the next question asks me, how high up in the tree is the squirrel? So I've got the same diagram here. I've got my dog, I've got my lovely tree. Squirrel! So squirrel's up there. Dog is still 7 meters from the base of the tree, and I still have a 50-degree angle of elevation. But this time, instead of wanting to know how far the dog is from the squirrel, I want to know how high the squirrel is. So I'll call that y. And again, my right angle is over here. So this time, as I'm looking at my sides, y is across from the 50 degrees, so that's opposite, and the 7 is still adjacent. So this time, I want to know opposite, and I already know adjacent. Opposite and adjacent, I'm going to use tangent, TOA. So the tangent of 50 degrees equals opposite y over adjacent 7. Since y is on top, this is a one-step problem. Just multiply both sides by 7. And you get that y is 7 times the tangent of 50 degrees, which is about 8.3 meters high. So those are problems like you would have seen on the 10.3 assignment. All right, let's look at the next problem. All right, this time we have a sledding run. So going down a mountain, and the sledding run is 400 yards long. And as you go down that run, from the top to the bottom of the run, you drop 40.2 yards. And we want the angle of depression. So what you've got to be careful of is it's not the angle inside here. Remember, the angle of depression is the angle outside the triangle. You take a horizontal line and you measure the angle below the horizontal line to that sledding run. So there are a couple ways we can go about this. One way we can think about it is that the 40.2 yards we could draw over here. Just as well as we can draw it on the other side. So if we look at it this direction, our right angle would be up there. The 400 yards would be the hypotenuse, and the 40.2 would be opposite that angle theta that we're trying to figure out. Opposite and hypotenuse, that would be sine. So this time we're trying to find the angle. So this would be a problem like section 11.2. We know that the sine of that angle is equal to the opposite side, 40.2, divided by the hypotenuse, 400. So in order to get the calculator to tell me how big the angle is, I use the inverse sign. You always use the inverse when you know how big the sine or the cosine or the tangent is, and you're trying to figure out how big the angle is. So second sine, 40.2 divided by 400. That gives me about 5.8. Now 5.8 what? It's an angle. We measure angles in degrees. So this isn't a very steep sledding run. You're not going down very steeply. It's not a very scary sledding run. All right. Let's look at another example involving an angle of depression. So you've got a plane, and your plane has a height of 25,000 feet. And your pilot, so the plane's right here, your pilot looks down at an angle of depression of 9 degrees. So straight ahead is horizontal, measure down from there 9 degrees. And you want to know how far away from the runway along the ground is she. So along the ground, we're looking at X. So there are a couple of ways you can approach this problem, because the 9 degrees is not inside that triangle. So a few things you can do. The first one is, remember that I told you that angles of elevation and angles of depression are always congruent. Since this line and this line are parallel, that angle, the 9 degrees, is congruent to this angle. So you've got a 9-degree angle inside there. That's one thing you can do. Another thing you can do, if you prefer, is you could say, oh, well, these two angles have to add up to 90. So 90 minus 9 is 81 degrees. And you could use that 81-degree angle. It doesn't matter which one you do. I'm going to use the 9 degrees. But if you use the 81 degrees instead, that would also be absolutely fine. So if I'm looking at the 9-degree angle down here, the 25,000 would be opposite, and the X is right next to that angle, and it's not the hypotenuse, so it is adjacent. Opposite and adjacent, that's TOA. So this is a tangent problem. So the tangent of the angle, 9 degrees, equals opposite 25,000 divided by adjacent, X. So since the X is on bottom, 2 steps, multiply both sides by X. You get X times the tangent of 9 degrees equals 25,000. Oh, that was weird looking 0. And then divide both sides by tangent of 9 degrees. And you get that X is 25,000 over the tangent of 9 degrees, which is about a long way. 157,844 feet. And in case you're wondering, that is feet. If you want to know how many miles that is, that's about 30 miles. So it's not completely ridiculous. Now this problem looks a little strange, but it's not as strange as it seems. So you've got a tree, and the tree's shadow is 30 feet long. Now the sun's angle of elevation, so just think about this for a minute. The sun is going to be up here. The sun is going to come down, be shooting off rays like this, and it's going to hit the top of the tree, just glance off the top of the tree and come down and hit the tip of the shadow. So the sun's angle of elevation will be the same as the angle of elevation from the tip of the shadow to the top of the tree. Like that. Now the tree's shadow is 30 feet long. And you want to know how tall the tree is. We'll call that X. So X is opposite your 42-degree angle, and 30 is right next to it, but not the hypotenuse, so that would be adjacent. We have yet another TOA problem. So the tangent of 42 degrees equals opposite X over adjacent 30. Well, this time X is on top, so this is an easier problem. Just multiply both sides by 30. And you get that X is equal to 30 times the tangent of 42 degrees. Which is about 27.0 feet. Okay, we've got another two-part question. We've got a building, lovely building, and we've got a ladder leaning against the building. Beautiful ladder. And the foot of the ladder is 7.2 feet from the base of the wall. And the top of the ladder rests on the wall at a point 15.4 feet above the ground. We'll assume that we're not talking about the Leaning Tower of Pisa, so the building is making a right angle with the ground. First question is, how long is the ladder? Well, let's see. I've got two sides of a triangle and I want the third side. If you know two sides and you want the third side, Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. This one's the hypotenuse. So leg squared plus leg squared equals hypotenuse squared. 7.2 squared plus 15.4 squared, 237.16, Add those together. $289. Take a square root, and you get x is 17. Exactly. That's kind of cool. Okay, so the ladder is 17 feet long. Now it wants to know the angle of elevation. So I'm just going to add that in here. That's that angle right there. Now you actually know all three sides, so pick any of them. Personally, I always stick with information that the problem gave me in case I made some sort of mistake figuring out the answer to the first problem. So I'm going to use the 15.4, which is opposite the angle of elevation, and the 7.2, which is adjacent to it. So that would be another TOA problem. So I'm going to use tangent. But if you want to use the 17, feel free. So I'm going to say the tangent of my angle theta is 15.4 divided by 7.2. So I need to tell the calculator, hey calculator, I know the tangent, you tell me how big the angle is. And I tell it to do that by using inverse tangent. So second tangent, 15.4 over 7.2. It's about 64.9 degrees. Would be my angle of elevation of that ladder. So draw the picture, think about what you're trying to figure out. If you know two sides and you want the third side, Pythagorean theorem. If you know one side and the angle and you want another side, use sine, cosine, or tangent. If you know two sides and you want an angle, use inverse sine, inverse cosine, or inverse tangent.